What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram. Drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
Alright. Okay, so today we'll be starting on Chapter 9, Trigonometry. Okay, so if y'all got any questions, right, I want y'all just put in the chat. We will try to cover as much as we can today in this next 1.5 hours or so. Okay, so Chapter 9, Trigonometry. I believe that all of you have some sort of knowledge with Trigo, right? Okay, and I think last time you all learned in your mathematics is your sine, cos, tangent, so ka tua, and who's that guy that y'all relate this so ka tua to? Something related to Trigo. It needs to be a right angle triangle, and yeah, the mathematician, or he's actually a philosopher lah. His name is Pythagoras, right? Okay, y'all can go online and maybe go to YouTube and also find out a bit more of who Pythagoras is. Okay, and then how did he actually come up with your a squared plus b squared equals c squared, which we will be using in this chapter also. Okay, so trigonometry. Okay, let's just look in the textbook, page 186. So there will be few things that we'll be learning. The first thing today that we'll be seeing is find the trigo ratios of any angle of any magnitude. Okay, so trigo ratios of angles. Okay, second thing that we'll be learning, amplitude and period. Okay, so second thing, amplitude and period. So these are definitions that y'all actually will be using in your science also. I think specifically physics, if y'all are taking physics. Then the third one, relationship between trigo graph. Okay, so we have SOHCAHTOA, sine, your sine, cos, tangent. And later on, we will also be seeing what is 1 over sine, 1 over cos, 1 over tangent. Okay, that one I think you all haven't learned it before, right? Then the next part, we'll be learning how to sketch the graph of sine, cos, tangent, and also a modulus graph. So modulus, as we've learned before, it's just whatever that's negative will become positive. Okay, but I think we all would need to learn on what exactly, how exactly a sine, cos, and tangent graph looks like first. Then this part here, specifically, if I have a y equals to a sine bx plus c, y equals to a cos bx plus c, and y equals to a tangent bx plus c kind of graph. Okay, so when I have this A, B, C, how would it affect my sine, cos, and tangent graph? And this has been a very hot question that has been coming up, okay, in the exam. Is in the first, it has appeared in the first 3 questions. So they will ask you to sketch this kind of graph out or determine what exactly is A, B, and C. The concept is actually very, very simple. Then trigonometric relationships, solving, and then proving. Okay, so relationship, solving, and then proving. Okay, so this is at a high level what exactly you'll be learning in Trigo. It's quite a lot of things. Trigo, I would say, is one of the harder chapters also. So you'll need to follow closely. And I actually want to try to finish it within the next 2 classes so that you all got time to do the work during the holiday. Okay, so I need you all to focus very, yeah, just put your focus for the next 1.5 hours or so. Okay, so everyone ready? Let's look in a textbook, page 187. Okay, so as of now, right, what y'all should know is soka tua, right? Soka tua, which is sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, tangent is opposite over adjacent. So we can look to this triangle if they give us a right angle triangle. Soka tua, you all have to remember, it only is valid for a right angle triangle. Okay, so right angle means 90 degrees. If my theta is here, and I use this as y, and this is x, and we put the hypotenuse as r, sine theta will be equals to so, right? So y over x, because opposite to the angle and then adjacent to the angle is x. Tangent, cos first, cos theta, which will be x over r, and then tangent theta, which is y over x. Okay, so these are the things that y'all need to take note of. These are very basic thing that y'all should know already. Okay, 9.1, angles between 0 degrees and 90 degrees. What do we call an angle that is 0 to 90 degrees, or between 0 to 90 degrees? There's a specific name for it. Angles between 0 and 90 degrees. It's called an acute. Yeah, acute one. Okay, because small, right? Okay, so if you remember it this way, because it's small, therefore normally small things are quite cute, right? If you see a small dog, a small kitten, very cute, okay, or small baby. Okay, so gotta remember that, an acute angle. Okay, so how do we find the sine cos tangent for an acute angle? Okay, meaning we only look from 0 to 90 degrees. Okay, later we'll see we can go beyond 90 degrees. We can also go negative degrees. Okay, so for now, this kind of method that we are going to use, going to be solving, only is valid for 0 to 90 degrees. Okay, so let's look at the question. Given that sine theta is equals to 2 over sec 5, and that the angle is acute. Okay, so sometimes they'll use this, angle is acute, or they will write it like this, 0 to 90 degrees. So you just need to take note of this. Okay, what do they want you to find? The other keyword that has been coming out in exam is the word exact. So when they say find the exact values of, you don't just use the calculator and then use the decimal place and all that appears in the calculator. You have to find in the exact value, such as cert. Okay, maybe like a cert 5. You don't go and type in the calculator and then calculate cert 5. Cert 5 or yeah, a square exponential value or ln value. So all those you leave it in exact value. If you round it up and you type in the calculator and then you find the decimal place, normally they'll give you 0 marks for it. So we have to follow this. So find the exact value of. Okay, let's do this 4 question. First one, sine square theta. Second one, cos theta. Third one, tangent theta. Fourth one, sine theta over tangent theta minus cos theta. Okay, so different kind of trigo questions have different method. So you all need to take note on what is given to you all. Theta. Okay. Okay, So let's look back into the question. The question gave us that sine theta is equals to 2 over sec 5. Okay, take note of this. So what is sine theta? We learned in Pythagoras, according to the right angle triangle, or it's called your trigonometric ratios, your soka tua. Sine theta is opposite over hypotenuse. So can I say that this is actually like the top value is opposite, the bottom value is hypotenuse, right? Make sense? And for us to have a complete picture, because if you look into the questions, they ask us to find all sine, cos, and tangent. So now the other thing I want all of you to do right now is go and draw a right angle triangle that is related to this 2 over sec 5. There's one more value that you all need to find, which is the adjacent side. Okay, so okay, I'll move all of this down first. Okay, let's draw the right angle triangle that we need to use. Okay, you don't have to draw like until a very nice one, as long as you know what you're doing. So 0 to 90 degrees. So we know that the angle, okay, let's just take this angle. The angle is less than 90 degrees. Okay, and more than 0 degrees. So we can assume it looks something like this. Okay, sine theta, so in relation to the theta, opposite is 2, hypotenuse is sec 5. So using Pythagoras theorem, can I find the adjacent side? Can, right? Okay, so the very first thing that you want to do is using your a square plus b square equals to c square, or you memorize it as a square equals to b square plus c square. Either way works. Okay, so for us to find the adjacent side, it will be a equals to, let's put it at a square first. A square equals to sec 5 square minus 2 square. Then square root, right? So use your calculator to calculate this. 5 minus 4 will be equals to 1. Therefore, a will be plus minus square root 1, but a value should be positive, right? Because you cannot have a negative length. So we only take it as 1. So here is a, which is 1. Okay, whenever they ask you to find, do this question, that means they give you a sine, cos, or tangent, some sort of value. Normally, it's a fraction. Sometimes it's a value also. You all have to put over 1. So just use the principle of so katoa, which is your trigo ratios, and then find this first. Okay? The next thing that you want to do, now you have this already, right? Okay, the next thing actually you want to do is to find what exactly is the value of sine, cos, and tangent, because you want the exact value. So you don't straight away type into the calculator. We follow according to this specific right angle triangle, which I have 1, 2, and then sec 5. Okay, so this is what we do. Okay, so look over here. Given to us sine theta is equals to 2 over sec 5. Cos theta, which is opposite over hypotenuse, adjacent over hypotenuse, which is 1 over sec 5, right? Okay, 1 over sec 5. And then tangent theta, which is ka. What am I talking? So ka. Tua. Not ta. Okay, tua. Opposite over adjacent. Okay, which is 2 over 1, which is equals to 2 lah. Okay, you can leave it like this, or you can go and rationalize the value also. You also remember what's the meaning of rationalizing? Where your bottom, your denominator, you don't want as the cert, right? So I can just multiply by the cert value, with both your numerator and your denominator. Okay, so this is the first step. You want to look into the question. Normally, they will ask you to find some sort of sine, cos, or tangent, or maybe all three of it. So the technique to do this question is that you draw out a right angle triangle first. Then you find out all the values of so ka tua first. Okay, then only you go and solve the question. Okay, let's look into the first question. Sine square theta. Okay, so sine square theta, if you all didn't know, if we want to write as a trigo square, right, we normally put the square in the middle, sine square theta, instead of writing it as sine theta square, because sine theta square can be a bit confusing whether the square actually belongs to the theta or the entire trigo value. Okay, so that's the reason why they put the square in the middle. Okay, so it's actually the same meaning. Sine square theta is the same meaning as sine theta square. All right, it's just the standard form on how they normally write it. Okay, so when we look over here, sine theta is equals to 2 over sine 5. What we can say is sine square theta is also, you can also write it as sine theta times sine theta, right? Or sine theta square, either one of it, which would give you 2 over sine 5 square or 2 over sine 5 times 2 over sine 5. Either way that you want to write also can. Go and multiply this. 2 over sine 5 times 2 over sine 5. 2 times 2, 4. Sine 5 times sine 5 will be 5. Okay, so your final answer will be 4 over 5. All right, let's move on to the second one. They say they want cos theta and tangent theta. So you all see just now why I did the triangle. So from here, I actually can straight away find the value already. Okay, so just refer back to the value up here, 1 over sine 5. However, if you look into your textbook, sometimes they rationalize the value. If they never ask you to change anything, normally you can leave it, it's not wrong. Okay, but if you want to rationalize it, means I don't want a cert value at the bottom, I multiply by cert 5 over cert 5, which would give me cert 5 over 5. Okay, you do this if they ask you to rationalize the denominator or to present it in a certain form. Otherwise, I would say just leave it. Okay, don't touch it. Okay, let's look at C. C has already been counted because of the triangle above. So tangent theta will be equals to 2. Okay, pretty simple, right? Okay, I want all of you to try this right now. Sine theta over tangent theta minus cos theta. Okay, I'll give you 30 seconds. Okay, sine theta over tangent theta minus cos theta with the values that we have counted already just now. Okay, 30 seconds. And I want y'all to rationalize it also. Okay, so y'all try rationalizing it. My mic clear, right? Okay. Okay, 30 seconds is up. So let's look at this. Yeah, put the equal sign here. Okay, sine theta, which is 2 over sine 5 over tangent theta, which is 2 minus cos theta. So you will get minus 1 over sine 5. Okay, so this is actually how you find your sine cos theta and then just sub it in. But normally they will want you to present it in a certain form. They means they want you to simplify it, or yeah. So we have to follow exactly what do they want. So now I'll go, right? So just as I told you all that I want you all to rationalize it and also to just give it in one numerator and one denominator. So we are trying to simplify the entire fraction here. So you'll see now got two layers, right? And on top the layer got 2 layers, at the bottom also got another 2 layers. So when you come across this kind of question, solve one layer at a time. Okay, don't confuse yourself by trying to mix all of it together, and then you also get very messy. Okay, if you follow according to the textbook, I just use the textbook method first. 2 over the thing is you all can look like this. 2 over cert 5 divided by 2 minus 1 over cert 5. Okay, 2 over cert 5 divided by 2 minus 1 over cert 5. So if you're wondering like how the textbook like suddenly jumped to that value, right? Okay, what they did here is my cert 5, I can actually bring it down and multiply with all the other values at the bottom. So it's actually like this. Okay, if you all are unclear on what the textbook is writing, so 2 over cert 5 times 2 minus 1 over cert 5. This is actually going back to your basics of fractions, when you all learn fractions and how to calculate A over B over C over D. Okay, so we multiply the bracket inside. 2 cert 5, then cert 5 over cert 5 will be equals to 1. Okay, so that's how they get 2 over 2 cert 5 minus 1. Next step, what do we want to do? Rationalize the denominator. So how do we rationalize the denominator when there's 2 terms? If it's minus 1, then we multiply by the plus value of it. So 2 cert 5 plus 1. And then the top also, the numerator, 2 cert 5 plus 1. Okay, so it'll be 2 times 2 cert 5 plus 1. Your bottom is actually A plus B, A minus B equals to A square minus B square. Okay, so the top you can just write it as 2 times 2 cert 5, right? Okay, so it'll be 4 cert 5 plus 2 over, so your A square will be what? 2 cert 5 square, which will be 20 minus 1 square, okay, which is minus 1 over 19. All right, in exam, normally they will ask you to write in a certain form, meaning they will say, present your final value in, or their exact value in A cert 5 plus B over C. Okay, so if you see the cert is on top, and then when you do your working, you see it's at the bottom, then you should know that you need to rationalize the denominator. Okay, cool, understand? Okay, so this is work example 1. All right, I want all of us to turn to page 188 right now. Okay, turn to page 188. I'll teach you all, this is called special angles. Okay, for trigo. Okay, this is for trigonometry. Okay, if you see at the bottom of the page, right, they say, note, you do not need to learn these triangles and ratios for the examination, but you may find it useful to know them. Actually, you need to use, okay, you need to know. All right, so I think the reason why they say this, because I think certain calculators can actually count the cert value. But if you are using, which is most of you, we are using 570, the cert value will just be calculated to, what do you call that? Decimal places. Okay, so we actually cannot get the exact value. So if the question asks you to calculate the exact value, then you would need to use these special angles. Okay, let me teach you all how to do these special angles. Okay, I think the silver calculator, like Brandon's one, you might be able to get the exact value immediately. Okay, so what are special angles, right? Is we want to find the exact value for this these three angles: 30 degrees, 45 degrees, and 60 degrees. Okay, so 30 degrees, 45 degrees, and 60 degrees. We want to find the sine, cos, tangent for these three particular angle. Okay, or if we write it in radian, it is pi over 6, pi over 4, and pi over 3. Okay, another thing to take note of, when you type into your calculator, if you want to calculate in radian mode, then make sure you change it to radian mode first. That means, let's say if we want cos pi over 6, okay, we want to type cos pi over 6, then make sure it's in radian mode. Otherwise, your value will be calculated in degree. By default, if you all see here, the calculator on top here is D, right? D is degree mode. Okay, so if what I will always do, I will always actually reset the entire calculator, shift mode 3, okay, which is you reset the entire thing. By default, it will always be in degree mode. All right, so make sure you all calculate it in degree mode. If you all are calculating degree in radian mode, then radian mode. All right, I remember there's this meme, like all this maths and science Instagram page. This guy said, "Oh, submitted my final year project or my final assignment for my entire degree after doing the paper for like 3 hours. But the only problem, he did the entire paper in degree mode when it's supposed to be in radian. So that means your answer, the whole working will be wrong. Okay, so make sure you look at it. Okay, always look in whether it's degree or radian mode, because it's a very common mistake that you put it in the wrong mode, you still get a value, but the value will be totally wrong. All right, okay, so I'm going to teach you how to use these two special triangles also specifically to solve 30, 45, and 60 degrees. Okay, that means I want to find sine 30, cos 30, tangent 30. Then sine cos tangent for 45, sine cos tangent for 60 degrees. Okay, two triangles and you all have to know how to sketch this triangle. So I want all of you to try also drawing this triangle. Okay, the very first triangle is to find 45 degrees only. Okay, so 45 degrees will be one triangle. Then 30 degrees and 60 degrees will be from the same triangle. Okay, let's draw the 45 degrees one first. To draw your 45 degrees triangle, you got to memorize this triangle. This is the easiest way for you to get this triangle. Okay, your two sides will be sides of length 1, 1. Okay, got to memorize this. The triangle, the two sides, your opposite and adjacent side, would be length of 1 and 1. You actually can put other values also, but we want the most simplified form because then it's easier for our calculation. So if I have 1, 1, what will be my hypotenuse? A square plus B square equals to C square, right? Then square root your entire value to find your value of C. So 1 square plus 1 square, square root. So for me to find my hypotenuse will be square root 1 square plus 1 square, which is equals to 2. So this is how you find this triangle first. Okay, you all gotta memorize this. Then put a 45 degree down here. So 1, 1, the length is 1, 1, this triangle. Okay, now I want all of you in the next 15 seconds, write down what is sine 45 degrees, tangent 45 degrees, and cos 45 degrees. Right, sine, cos, tangent. Okay, sine, cos, tangent, 45 degrees, 45 degrees, and 45 degrees. Okay, not asking you to type in the calculator, find the exact value according to this specific triangle. All right, 15 seconds. Let's go. Okay, I want all of you to be sketching out this triangle because you need to practice so that you know how to do it. Okay, 45 seconds done. Sine 45 degrees, so will be 1 over sec 2, right? Because so kata, right? So opposite 1, hypotenuse sec 2. Ka, same thing also, because your adjacent is 1, then hypotenuse is sec 2. Then next one, tangent, so ka tua. So tua will be 1 over 1, which is 1. Okay, so if they give you the value of sine 45 degrees or sine pi over 4, okay, I hope you all remember how to change from degree to radian, because that was discussed in the previous chapter already. So sine 45 is 1 over sec 2. If you want to write it in, if you want to rationalize it, it will be sec 2 over 2. You just multiply by sec 2 over 2. Sec 2 over sec 2. This one also sec 2 over 2. Then this one will be 1 lah. Okay, so you don't have to rationalize it if they are not asking you to rationalize it. Okay, so sine 45 degrees or pi over 4 will be 1 over sec 2. Cos 45 equals 1 over sec 2. Tangent 45 equals to 1. Okay, you can actually double check the value by typing it into a calculator. Okay, I want those who have the silver calculator, I think only Brandon, right? You type sine 45 degrees. Do you see if they will give, if your calculator will give you 1 over sec 2 or sec 2 over 2? Okay, but for the rest of you, when you type in sine 45 degrees, you all realize that, you see what they give you? 0.70710671, right? Okay, how do you know your exact value is the same or whether it's correct or not? Just type in 1 divided by sec 2. You see, the exact same value, 0.7071. Okay, we don't need so many lah, because normally they ask us to write in just 3SF. Okay, so if you want to double check whether your exact value is correct or not, always use the calculator, type it in again, just to double check. But the more you do already, you realize that, oh yeah, actually, I know some students who actually memorize this whole thing also. You can go and memorize it. But the thing is, just in case you all forget, you all actually can derive it from this triangle itself. Okay, clear? Okay, let's move on to the second triangle. This triangle is for 30 degrees and 60 degrees. So this one is for this orange color. This one is yellow color. Okay, so this is for, just right here, 45 degrees. This is for 30 degrees and 60 degrees. Okay, the next triangle is slightly different. What you need to draw is you need to draw an equilateral triangle, okay, which is all same sides with sides 2. Okay, and then we cut it into half. Okay, so I'm going to sketch this out for you. So let's draw an equilateral triangle. Okay, equilateral means all same sides, right? Like this. Okay, but we don't want the whole thing. We only take half of it. So we cut it into half. Okay, so cut this into half. So I only look at half of it. Okay, this is this one. Okay, if I look into half of it, what is the angle for an equilateral triangle? 60 degrees, right? Because all equal. So here will be 60 degrees. Here also 60 degrees. And if I cut into half, what will happen? Here will be 30 degrees. Okay, and then here will be 90 degrees. Just now, another thing I said, it is an equilateral triangle with sides 2. So if it's side 2, where will be 2? Here will be 2, here 2, here also 2, right? But now my bottom, my 2 cut into half, so become 1, 1. So here will be 1. Okay, so here will be 1. And here also 1. But we need to look at one triangle, so you don't have to draw the other side also. It's just, I'm just teaching you all how we actually derive this triangle out. Okay, then the next thing, how do we find the final side? Okay, which is the opposite from 60 degrees. So we use Pythagoras again. So Pythagoras, when we use Pythagoras, what will happen is we will use 2 square minus, let's just put this as A, 2 square minus 1 square square root. So 2 square minus 1 square will be cert 3. So this side will be cert 3. This is how you calculate the last side. Okay, so you see, according to this triangle, we got both 30 degrees and 60 degrees here. So 30 degrees and 60 degrees, I want all of you, okay, going to give you 1 minute to do this. Find your sine, cos, tangent for 30 degrees, 30 degrees, 30 degrees, and then sine, cos, tangent for 60 degrees, 60 degrees, and 60 degrees. All right, according to this triangle. Let's go. All right, 5 more seconds. 4, 3, 2, 1. All right. Okay. Let's look at 30 degrees first. So the 30 degrees is at the top, right? Okay, so 30 degrees, so the so will be, according to this, so will be 1 over 2, right? So 1 over 2. Cos, ka, adjacent over hypotenuse, so cert 3 over 2. Tangent, toa, 1 over cert 3. Understand the logic behind this? It's actually applying whatever we have learned before, just that now we are expanding on it. So your soka tua. So sine 60 degrees will be so cert 3 over 2 cos 60 ka 1 over 2 tangent toa, okay, which is cert 3. Correct. Yeah, cert 3. All right. Okay, so yeah, so this is how you all derive your sine, cos, tangent for 30 degrees, 45 degrees, and 60 degrees. Okay, if you want to double check whether your value is correct, once again, use your calculator to check. You want to rationalize the denominator, also can. You all know how to rationalize, right? Because from the, I think, chapter 2 or 3, we learned how to rationalize the denominator. Okay, so these are called special angles for your trigo. You need to know. You need to know, because when they ask you to find in exact values, and then you're working, there's a sine, cos, or tangent 30, 45, or 60. Have to keep this in mind. Either sine, cos, tangent 30, 45, 60, or pi over 6, pi over 4, or pi over 3. Then you will need to use these two triangles to derive the formula if your calculator cannot give you the exact value. Okay, so now let's look into work example 2. Okay, work example 2, we actually need to use these values. So since we derive already, work example 2. Okay, now they say find the exact value. The keyword is exact, exact value of A sine 45 degrees, sine 60 degrees. Second one, cos square 45 degrees. C, tangent pi over 3 plus sine pi over 4 over 1 minus cos pi over 3. Okay, so they can put it both in degree or radian mode. It will be the same thing. And if they write it in degree, then there will be the degree symbol. Okay, so let's try this with the 9 sine cos tangent 30, 45, and 60 degrees that we have. We can actually just put into this question. So let's look at this. Sine 45 degrees. So we go find out what is sine 45 degrees. 1 over sec 2. Sine 60 degrees will be sec 3 over 2. So times sec 3 over 2. So what will you get? Just multiply it. Sec 3 over 2 sec 2. Okay, let's have the habit of rationalizing the denominator because that is the standard form that your textbook use. So times sec 2 over sec 2. Your bottom, you'll get 2 times 2, so it becomes 4. Your top, sec 3 times sec 2, square root A, sec A times sec B will become sec AB, so you can write it as sec 6. Okay, so your final answer will be sec 6 over 4. Okay, let's look at the second one. Cos square 45 degrees. Square, if it's in the middle, is equivalent to my whole trigo cos 45 square. Okay, or you can write it as cos 45 times cos 45. Either way works. So if you want to write it like this, cos 45 times cos 45 can. Let's look back into the list. Cos 45, we found that is 1 over sec 2. So 1 over sec 2 times 1 over sec 2, which is equals to sec 2 times sec 2, 2. Okay, so 1 over 2. Let's look into C. Tangent pi over 3 plus sine pi over 4 over 1 minus cos pi over 3. For me personally, I like to think in terms of degrees, so I always change it to degrees. Okay, but this one, I think try to get used to radian also lah. So you all can immediately see and then know like what is the degree of it. So pi over 3 will be 60 degrees. Okay, I just write here. So because pi is equals to 180 degrees, so 180 divided by 3 will be 60 degrees. This one pi over 6, and this one will be pi over 4. Okay, so tangent pi over 3 means tangent 60 degrees. So tangent 60 degrees, we look up to the list, it will be equals to sec 3 sine pi over 4, which is sine 45 degrees. So we go to the 45 degrees there. 1 over sec 2 over 1 minus cos pi over 3. Pi over 3 would be 60 degrees again. So 1 over. Is it 1 over 2 or 1 over sec 2? Oh, sorry, I gave your one wrong value here. This is 1 over 2. Ka. Okay, there's no sec there. Okay, so 1 over 2. Okay, let's simplify this entire equation. Okay, you might be seeing the textbook also suddenly. How come become 1 minus, then just times 2, right? Okay, let's break it down one step at a time. We do the, I normally separate like this. You solve your numerator first, then you solve your denominator also, then only we join it together. Okay, don't try not to mix both of it. So the top, we actually can just leave it as sec 3 plus 1 over cert 2, depending on what's the final form that they want you to show also. 1 minus half would be 1 over 2. Okay, so your numerator divided by a fraction, if you all look at it like this, A divided by B over C is also written as A divided by B over C, which is equals to A times C over B. Okay, you need to be able to break it down to like this. Normally the issue is that most students forget their basics again, okay, for fraction, so they get a bit confused. So you divide by half means you actually times 2. Okay, if I divide by 1 over 2, if a numerator and denominator, means I actually times 2, because times 2 over 1. So that's how they actually get the times 2 there. So 1 over cert 2, the whole thing, times 2. Okay, so I know I got times 2. Here will be 2 cert 3 plus 2 over cert 2. If you want to rationalize it, over here I can write times cert 2 over cert 2, which will be 2 cert 3 plus 2 cert 2 over 2, 2 cert 2 over 2, which will give me cert 2. Okay, so your final answer will be 2 cert 3 plus cert 2. All right, any questions here? All good? Following through? Okay, cool. Okay, so this is the entire 9.1. Using trigonometric ratios, which is your so ka tua, to find the value, to find a specific value or the exact value. Okay, so when in exam they ask you to find exact value, don't go and use calculator and then straight away give the decimal place value. You will get no marks for it. Okay, so why they want you exact value is because they want you to derive the formula, okay, of your sine, cos, and tangent. Cool. 9.1 done. Okay, let's move on to 9.2. 9.2. The general definition of an angle. Definition of an angle. Okay. So you need to be able to use 3 basic trigo functions for any angle. Meaning, if I give you any sine, cos, tangent, and then ask you to find a specific degree, it might be 180, it might be 360, it might be 273.3, it might be 395.9, it might be 1000. Okay, you all need to be able to understand and to know how to find a value. To find a value, actually very simple. You just need to type in a calculator. Calculator will give you a value, but we need to understand the logic behind. Okay, so I'm going to teach you all this thing first. So we're going to look into 4 quadrants. These 4 quadrants, okay, can be written, can be drawn like this. Okay, so quadrants are, it's just an X and Y. Okay, so quadrant means quad, right? Quad means 1/4. Okay, so every quadrant has 90 degrees. Okay, so what do we call it? Or how do we define in terms of quadrant for the angles? We actually start from here. This will be called your first quadrant. Okay, you're going to remember this term, quadrant. Okay, if you're suddenly like, what is quadrant? Just remember the word quad. Okay, quad, 4, 1/4. Then we go anti-clockwise. So you all got to remember, we start from here the x-axis, this is 0, so it goes like this. Yeah, it goes like this. Your second quadrant will be here. Second quadrant. Okay, so we go anti-clockwise. Third quadrant is here. And then this is your fourth quadrant. Okay. So how do we understand this? This first, second, third, and fourth quadrant. If you all look here, you see they draw this angle here, right? And then they say P. Okay, let's look here. An angle is a measure of the rotation of a line OP, O is your origin, about a fixed point O. The angle is measured from the positive x direction and anti-clockwise direction. So anti-clockwise, which is from here to here, is taken as positive. So if I go anti-clockwise, it's positive. A clockwise rotation is taken as negative. So if I go in this direction, this will be negative theta. Okay, you all gotta remember, going clockwise is not like, this side is not like a clock where you go clockwise. Going clockwise for this angle, you will get a negative angle. Going anti-clockwise, you will go as positive. Okay, so this is negative theta. The Cartesian plane is divided into 4 quadrants and the angle theta is said to be in the quadrant where OP lies. In the diagram above, theta is in the first quadrant. So I'll teach you all how to understand and to define what is the angle according to these 4 quadrants here. Okay, so you all now just need to remember first quadrant, second quadrant. So first quadrant, second quadrant, third quadrant, and then fourth quadrant. Okay, so 1, 2, 3, 4. Start from first quadrant. Going anti-clockwise is positive. Going clockwise will be negative angle. Okay, so it's literally, we are actually counting angles. So one whole round will be 360 degrees. Okay, so let's look at the work example 3. Okay, they say, draw a diagram showing the quadrant in which the rotating line OP lies for each of the following angles. In each case, find the acute angle that the line OP makes with the x-axis. Okay, acute angle means less than 90 degrees, right? So they say we want to find the acute angle that the line OP, so we're going to draw a line OP that makes with the x-axis. Specifically, x-axis are not to the y-axis. Okay, then there's a reason why we want to find to the x-axis also. This later we'll be using this angle. It's called a reference angle or base angle. I like to call it base angle because it's much shorter to say, but it's the same meaning. Okay, but I'm going to teach you all how to do this first. So let's look at the first one. They want you to draw 240 degrees. Okay, I'm going to teach you all the first one first. 240 degrees. So positive 240 degrees means I start from here. Okay, this is actually 0 degrees. Okay, you all got to remember, we start from here means 0 degrees. 240 degrees, and every quadrant has 90 degrees, right? So you all got to think like this. Every quadrant has 90 degrees. So where would 240 degrees, in which quadrant would it fall in? My first quadrant is from 0 to 90. My second quadrant is from 90 to 180. Okay, in between, not from 90 to 180. In between 90 to 180. Third quadrant, I just write this, 0 to 90. This is 90 to 180. This will be 180 to 270. And then here will be 270 to 360 degrees. Okay. Okay, so now look back at the question. 240 degrees, which quadrant would it fall in? Third quadrant, right? Okay, 240 degrees. So let's just draw it over here. Okay, let's put it as a red line. This would be OP. How do we draw the angle? Like this. So from 0 to here, this will be 240 degrees, the red line. Okay, so this is the first part on how we draw the 240 degrees. Then the second part, in each case, find the acute angle and the line OP mixed with the x-axis, right? So I'm going to use another color here. So line OP is this red line. So with the x-axis, we find this theta here. Okay, so OP and the line, the x-axis line. So here will be what? 240 minus 180 degrees because we minus the 2 quadrant. So here will be 60 degrees. Okay, so the acute angle is equals to 60 degrees. There's a reason why we are learning this acute angle. Okay, I want all of you take the next 1 minute, try B, C, and D. Okay, B will be negative 70 degrees. C would be 490 degrees. And then D would be, what's this? 2 pi over 3. Okay, 2 pi over 3. You can present it in terms of pi. Maybe try to get used to it. But in my mind, normally how I calculate it, I will change it to degree mode. Okay, so try next 1 minute. All right, 1 minute is up. Okay, let's look at B first. So they say they want you to find negative 70 degrees. So for me to find negative 70 degrees, negative, the value negative is important. So negative means I have to go in the clockwise direction. So we need to determine which quadrant is it at. So negative 70 degrees will still be in the, it will only take up one quadrant, right? But it will be in the fourth quadrant. So my OP will be here, right? And then my angle here will be negative 70 degrees. This is how we write as negative 70 degrees. Okay, but the theta, how we define it, the acute angle with the x-axis will be 70 degrees because this the theta lah. Theta will be equal to 70 degrees. Okay, 490 degrees. We know that one round, one revolution is 360 degrees. So you can go beyond one round. That means you just keep going and going and going. So it depends on how many, it depends on the angle lah. So 490 degrees, if you want to think about it, you can think like this. 490 minus 360 will be 130 degrees. So we want to determine which quadrant is it at, right? So we know that one round is more than 360 degrees. So I left another 130 degrees. So another is 360 degrees plus 130 degrees. Where will it end up at? It will be in the second quadrant. So how do we draw this this angle? We like that. We start from here. let's say my first one will be like this, then go all the way until here. Okay, because another 130 degrees. Okay, I might not be drawing it until very accurately. So we draw here, just need to know which quadrant is it at. So this 0 degrees, then, okay, how we define, this is like my first point here. So you see, I draw a black dot there. This is like the 0 degrees. Then this second part will be 360 degrees onwards. This is normally how we present it. Okay, the textbook never write all this, but this will be helpful guide for you all. So you all can add this. So we start from 0 degrees. That means the second number will be the second time the red color line intersects that x-axis point. Okay, so this whole thing is 490 degrees. And what do we know about the angle? Because here to here is 130 degrees. So this angle here, the theta, would be equals to 50 degrees. Okay, so the acute angle, okay, the acute one is 50 degrees. Okay? All right. Last one, 2 pi over 3. I always convert from 180 degrees because the basic rule that you all should know is pi is equal to 180 degrees. So everything we bench it, we take 180 degrees as like the benchmark. So 2 over 3 pi means 2 over 3, 180 degrees. That's how you calculate it very fast in your head. So 2/3 of 180 degrees will be 120 degrees. So 120 degrees, where would it be? It will be from here all the way to here. Okay, plus another. Okay, so over here. So this is my OP. So this red color angle will be 2 pi over 3. Okay, so 2 pi over 3, it is 180 degrees. So my over here, my angle, my theta here will be pi over 3. This is in terms of radian mode. But if you really feel that you cannot calculate in radian mode, what would be helpful is that you change it back to degree mode first. But your final answer need to present in radian mode if they ask you to calculate in radian mode. Okay, so this is how we actually draw angles. Okay, in this 4 quadrant. Okay, in your entire syllabus, these 4 quadrants will be something that's very, very important for you all to know. Okay, so the first thing is understanding the logic behind how to write your angle first. Okay, let's move on to 9.3. Okay, everyone finish writing? All good? Okay, let's move on to 9.3 right now. Trigo ratios of general angles. Okay, Trigo ratio of general angles. Okay. Let's see what's here. Okay, in general, trigo ratios of any angle theta in any quadrant are defined as y over r cos theta x over r tangent theta equals to y over x. You have to look into that triangle there. Okay, so they define your x and y, then your hypotenuse is r, where x and y are the coordinates of the point P, and r is the length of OP, and r equals to square root x squared plus y squared. Technically, they're just using a Pythagoras theorem. Okay, the main thing here, let's just summarize what they are trying to say. They're just saying that you need to know what is your SOHCAHTOA always. Okay, and we can actually apply SOHCAHTOA if we draw like this. Okay, let's just draw a circle. We draw it like this. And then what I do is, let's just draw a triangle inside. Okay, and this is my OP. So there's always an angle that we want to reference it to. And then we want to find the value of this OP. Okay, so if I say this is XY, okay, according to my coordinate, if P is XY, that means here is X and here is Y, right? And then it's a 90 degrees. This is my theta, and this will be called R. Okay, so if we define as XY and your hypotenuse, which is your SOHCAHTOA, we can write as sine, cos, tangent theta. Okay, sine, cos, tangent theta will be what? So you derive it out according to X, Y, and R. Normally, we wouldn't really use X, Y, and R. So yeah, it depends how you want to present it. But you just need to understand the concept of SOHCAHTOA. So Y over R, X over R, and then Y over X. Okay, so you need to understand the values of this. I'll teach you all easier ways to know how to apply this. Okay, so sometimes the textbook I think can get a bit confusing because they're telling you too many things. Okay, we're gonna learn this acronym ASTC. Okay, according to your textbook, it says all students trust Cambridge. Yeah, I don't know how much you all trust Cambridge. You all don't even know what Cambridge is, right? Okay, it's a board. Okay, you are taking Cambridge IGCSE for your exam, right? Cambridge. Okay, but yeah, the version that I remember is all students take care, or can be your year 11 friends. All students take Coke. That's what they say. Okay, all students take Coke. The main thing you need to remember this acronym. All ASTC. Okay, ASTC, ASTC. So tonight you all say it 100 times. ASTC. And what I'm referring to is here. According to the 4 quadrants, like this. A, S, T, C. Okay. And why do we need to know what's this acronym representing? It means what is positive in the quadrant. Okay, what values are positive in the quadrant? So ASTC, all students take care. What we are finding here is what trigo is positive in which quadrant. Meaning, all means in the first quadrant, the value of sine, cos, and tangent are all positive. Okay? In the second quadrant, only sine value is positive, which means cos and tangent. So if I give you a cos and tangent value in the second, that falls in the second quadrant, your value will be a negative value. Okay, take note of this word, value. Okay, so it will be negative. If in the third quadrant, only tangent will be positive, which means sine and cos will be negative. For the fourth quadrant, only cos is positive, which means sine and tangent is negative. Okay? We're going to just go another 2 examples, then we're done for today. Because I don't want to overload you all. This is quite a lot, right? 9.1 to 9.3. Okay, so let's look at how do we apply this knowledge, this ASTC. Okay, all students take care, especially now in the time of COVID. Okay, so you all better take care. Okay, so let's see work example 4. Okay, so they say express in terms of trigonometric ratios of acute angles. Okay, the first one, cos negative 110, 110 degrees. So let's just write what exactly is 110 degrees first. So they want it in acute angle. So they're always choosing the acute ones. Okay, let me duplicate this. Okay, we need one more later. Okay, so cos 110 degrees, as we know, it goes in the clockwise direction, and here is your 0 degrees. Cos 110, which quadrant will it be at? So you need to start training your mind to relate it in these 4 quadrants. So cos 110 is beyond 90 degrees, so beyond the 4th quadrant, which will go into your 3rd quadrant. So my angle will be over here, from here all the way to here. Okay, so this will be my why I draw it like that? Okay, so here is negative 110 degrees. So it's 90 plus 20 degrees. Okay, so when they say, right, present, express in terms of the trigo ratios of acute angles, means we want to find what exactly is the base angle or reference angle. So just now we find the theta, right? There's a reason for it. Okay, later on we'll apply even more. So you just need to know that if they give you cos 110 degrees, it will be equivalent to what you write as the acute angle. So you see, okay, you see this theta here is equals to 70 degrees, right? Okay, then we follow also ASTC. ASTC says that at the 3rd quadrant, only tangent is positive. Therefore, cos will be negative, right? So let's break it down. How to do this? So we can actually say cos negative 110 degrees is equals to cos 70 degrees also. But we need to add a negative to it because it is in the 3rd quadrant. Okay. So this is actually how we equate the value in terms of acute angle. This acute angle, we will later refer to it as reference angle or base angle. For me, I will call it base angle. Okay, I want you all to check. Use your calculator. You all type cos, then you can just bracket it, negative 110 degrees. You see what you all get? Negative 0.342, right? Negative 0.342. Okay, remember this value. Now I want you all to type negative cos 70 degrees. And you all see? The value is exactly the same. Also negative 0.342. So what does this mean? Actually, there's a relationship between your acute angle and whatever trigo angles that they give you. So you can actually convert it to something, your angle to this thing called base angle, which is an acute angle. Okay. Try the second one, sine 125 degrees. Sine 125 degrees. So sine 125 degrees will be in second quadrant. You go until here. So it's 90 plus 35, right? So extra another 35 degrees. Here OP. Okay, so this is 125 degrees. What would be my base angle or the acute angle? Will be 180 minus 125, which would be 55 degrees. Okay, so we want to find what is the value of sine 125 in an acute angle. So sine 125 degrees will be also equals to sine 55 degrees. Then we check, is it positive or negative? In the second quadrant, my sign is positive. Okay, my sign is positive. Therefore, sine 125 is equals to sine 55 degrees. Okay, how can we be sure? Let's just check. Sine 125, 0.8191. Sine 55, also 0.8191. Okay, positive and negative value is totally different things. So you all have to take note of whether it's positive or negative. Okay, clear? This is how we actually convert the value into acute angle. Okay, let's go to the last one for today. Work example 5. Okay, work example 5. Oops. Okay, what they say? Given that sine theta, let's move this further a bit. Sine theta is equals to negative 3/5. That 180 degrees to 270 degrees. So that means they give you these angles for a specific reason. It is referring to which quadrant is it at. Okay, so if you all think about it, where exactly is 180 degrees to 270 degrees? It's in your third quadrant, right? Which is what I drew just now. Okay, the first quadrant 0 to 90, second one 90 to 180, third one 180 to 270, fourth one 270 to 360. Now what do they want you to find? Find the value of tangent theta. Okay, find the value of tangent theta and the value of cos theta. So they give us what? Sine theta first. So when they do this kind of question, this is what you need to do. You need to draw it out first. Okay, draw out this sine theta first. So they say sine theta is at third quadrant because in between 180 to 270. So the steps you follow here. You need to draw a triangle out. Okay, draw a triangle, and then you see the angle is until here. So we actually don't know what is the theta. They never give us what's theta. They're not asking us to find what's the theta also, but they want the value of the tangent theta and cos theta. So what is theta is actually like this. This is called your theta. Okay, whatever theta is. But we know that the theta falls in the third quadrant. That's what's important. Okay, so knowing this, what do we know? ASTC, right? ASTC means in my third quadrant, my sine theta and cos theta will be negative. Only tangent theta will be positive. So the value, what do I mean by value actually is by all this. Okay, like negative 3/5. This is called a value. So you all see, you all observe why they write sine theta equals to -3/5 is because it's in the third quadrant and sine value will be a negative. Okay? All right. Now what you need to do, you look at this sine theta equals to -3/5. You treat the theta as use your theta as your base angle because it will be the same value. Okay, so you draw this theta, write this theta here, and then this theta, right, we use back to SOHCAHTOA again. This is opposite, this is hypotenuse, right? So your value of, you just look at the value, don't care about the positive, negative, because it's already factored in. You see, according to theta, so opposite will be here, 3, and then here will be 5, because that's your hypotenuse. Okay, we are now looking at this triangle here. Okay, this specific triangle here. You see it? This triangle. To find the value, if I got 5 as my hypotenuse, one side is 3, the other one will be 5 square minus 3 square square root, which will give you 4. Okay, this will give you 4. Okay, I do a bit different from the textbook also. Actually, wait, maybe I teach you the textbook way, that I teach you the logic behind. Just now I say don't need to care about the negative, right? Let's just put it as the negative. You see, going down is negative, and going left also negative. So here is also negative. So the 4 is actually negative also. -4. Okay, now according to this triangle, can you find the cos theta and the tangent theta? Can, right? Okay, so cos theta, according to this, will be ka. So ka, A, which is -4, H, 5. So -4/5. And tangent theta, TOA. TOA, -3/-4. Okay, -3/-4, which will give you 3/4. Okay, so this is how you actually get the value. If they give you, they structure it this way, they give you a specific value for a sine, cos, or tangent. They tell you which quadrant is it at, then ask you to go and find the other sine, cos, or tangent, the other triangles. Okay, one thing I want you all to observe. I'll just transfer the sine value here also. So just now they give us a sine theta equals to -3/5. So you all look over here, right? Sine, cos, and tangent, all this is in third quadrant. Does it obey the law or not of your ASTC? ASTC says that third quadrant, only tangent will be positive. Okay, so if we follow according to, you just treat it like coordinates. So -4, this one -3. So in third quadrant, it says that only T is positive. Cos and sine is negative. So you all see this value here? Does it obey? Sine theta, which is supposed to be negative, is -3/5. Cos theta equals to -4/5. Tangent theta is the only one that's supposed to be positive, which is found as negative 3 over negative 4 equals to positive 3 over 4. Okay, so you see, when we follow according to the rules, it will satisfy the ASTC for the angles. Okay, so this is how you all do work example 5. So we have actually cleared from 9.1 to 9.3 today. So just a short recap of what we did. The first part is knowing how to find your, according to acute angle, the exact values, angles between 0 degrees to 90 degrees. The second part is to know how we learn this new thing called ASTC, your 4 quadrants, and ASTC. Sorry, the 4 quadrants first, not yet ASTC. Then the third part, we learn about ASTC, the logic of what is ASTC. Later, we'll be expanding even more on this. Okay, so we'll stop here for today. I want all of you to do from exercise 9.1 to exercise 9.3. Okay, cool. All right, I'll stop the video here first, then you all can ask any questions.